Get started in 1 minute. All right, let's kick things off. Does somebody want to volunteer to take notes today? Javier, are you volunteering? Cool. Any new faces? I don't think so. I think everybody's been here before. Release planning and updates. So I'm going to take platform first.
Yeah, as far as I'm aware, there's nothing new on platform just yet scheduled, so we'll keep you posted.
Similar update on the lifecycle side.
Any updates from learning or distribution teams? Seems like no. So we'll jump into our weekly RFC review. Seems like the first thing is to depend about. So the second thing is add proposal for a shared layers directory. Sam, where are we at with this one?
I think Terrence left some comments and Jesse left some comments, and I think Emily left some answers as to why we chose certain things.
Also seems like just a lot of active discussion still.
Yeah.
Does it need to go on the agenda this week or? Good day.
Yeah, sure.
You're gonna put on the agenda?
Yep.
Buildpack authors tooling subteam. This is an FCP approved. Terrence, you want to help push that one through? Looks like it closes today. Oh, you're muted.
Yeah, I can push it through.
Sounds good. Next one is make build layers read only for subsequent build packs. Looks like this one needs some more approvals. Sam, any status update on this one? Anything you're looking for? Just
I think so. I've not read through Emily's comments yet. I think last time in one of the meetings we were discussing some alternates. I think Terrence brought up the fact that this would currently silently fail. Like if some build packs were expecting to modify layers from another build pack, rather than giving them any warning or error message, we just discard those changes, which would be sudden. And as far as I can see, this would apply to existing build pack APIs as well. Like there's no change on the API side, it's just the lifecycle discarding those changes. So that was the one question we had, is whether we want to calculate the the digest for each of the layers, and then if they change between build packs, throw a warning or an error.
Seems like that'd be expensive though. But we can. Do you want to put it on the agenda, or should we?
Yes. Okay.
Make build layers. No, sorry, that was what we talked about. Blocked add setting default command arguments that can be overridden by the user. This is blocked on larger changes to processes. I think Emily was going to open a new RFC. Anything else on this one this week? Cool. Disambiguate layer metadata files from app metadata files. Where are we with this one?
I think Jesse owns this now.
Yeah, I'm taking over on this. I got some information from Emily recently to kind of finish up, so I'll probably try to get that by next week. I'll try to have an updated RFC.
Sounds great. And that concludes our RFC review. So we'll jump over to an announcement. So we're moving this working group meeting to 10 a.m. tomorrow, 10 a.m. Eastern time on Thursdays to kind of better support folks in other time zones.
And this is starting next, right? Not tomorrow.
That's correct. We're not going to have two of these meetings this week.
Okay.
We're moving the meeting to Thursdays. Yeah, sorry.
So I know we'll announce it in the announcements and update the Buildpacks IO calendar. Is there any other place that we need to voice this change?
I might try to move the invite with the 500 people on it, but it hasn't worked in the past with Outlook. So we'll see. I might just cancel the existing invite.
Cool. And I know that there's discussions about maybe potentially changing the format. I would think that if we wanted to post it onto the newsletter, we'd want to do it when those changes are formalized. Does that sound good?
All right, next thing is SBOM draft.
May I just ask a question? Are we keeping the office hours on Thursday as well? So we're going to have 2 meetings on the same day. Okay, great. Thank you.
Next one is SBOM draft.
Yeah, I see Forrest is here. I don't know if I know folks from the Paketo side had some comments on the draft, and like they also had some opinions on how this should be implemented. And I think, let me open up the, let me share my screen first, sorry. Okay. I think one of the open questions was like, what do we gain from having a structured format versus what do we lose from the current free form metadata table that BOM is? And I think one of the points that came up was whether we even want to do something like this. So currently there are like a lot of fields that existing Buildpacks put into the BOM. They would, if they're not generating these BOMs from from an existing tool, they would have to figure out where these things would go. And that may be harder for the Buildpack authors to figure out, like mappings between where their fields currently are and where they would end up going. So for the Paketo case, it was things like the dependency, source URI, and SHA. I think I wrote down some solutions. So currently, Cyclone DX has a free-form key value store called properties available for almost any component in the SBOM. So like things like components or the top-level metadata, almost everything has the free-form properties table, which could be used as a substitute for this. The other question that came up is what happens when like when you want to convert between different formats, um, like if there is a one-to-one mapping between the different SBOM formats, and if information would be lost. So I think one of the alternatives proposed was for Buildpacks to have its own internal BOM format, which would then map to the various other BOM formats that exist in the wild. I'm not sure how I feel about that, because then we'd be inventing a n+1 BOM format that we would then be responsible for converting into the other n formats and figuring out the mappings for. So I'm not too sure about that. I think the other question that came up was like the format of the BOM itself. So as we'll be creating these bill of materials, since there is a lot of existing tooling and these tools output a fairly large BOM, we can no longer like put it on like the label as we currently do. So we have to store it in some file. Now the option is to store it as it is in the launch toml or layer tomls, but that might break how like these BOMs are represented, because things like SPDX or Cyclone DX have their own SBOM documents, and they expect the schema of that document to look a certain way. So then we'll have to figure out a mapping between these documents and the BOM table we have in the layer toml. So my proposal was to separate it out into a different file entirely, would which would either be XML or JSON, um, leaning towards JSON, because that's the sort of format that a lot of BOM generation tools in the wild support. I've not seen a single tool support TOML, so unless we really, really want everything to be in TOML and like have Buildpack authors convert JSON to TOML and vice versa, my suggestion was to like currently it was to just allow uh, authors to just put it in XML or JSON format, and then for the life cycle to just store it and merge it however it wants. But I think the conversation was that we should pick one, which is JSON, and leave the responsibility of conversion to the author. And I think the other question was whether we want to merge the BOMs produced by different layers and the launch toml, which was around like whether we want separate layer level BOMs. As far as I can tell, we currently already merge the BOMs from different places, and we could still have a unified BOM merged from different layers or launch tomls, but just indicate where it came from to point to the origin, which I think is sort of what one of the Paketo Buildpack library does. I think libpack maybe, where it inserts the layer ID or the Buildpack ID in the BOM as metadata. So I think we'll just be porting over that concept, but it is still useful to have a single BOM for the container image, because that is typically what a lot of container scanning tools that do CV detection or license detection take in. The last bit of question that may concern platforms is currently we use the RFC in its draft state proposes Cyclone DX as the the BOM format that things would be stored in, because it looks like it's more extensible and there's more tooling around it, especially more Go tooling that can be used directly without shelling out to something. So um, the current RFC puts the onus of converting between different BOM formats onto platforms or their helper CLIs. So the idea would be that the BOM would be stored with the image itself, and then the platform, like something like Pack, which currently already has an inspect image minus minus BOM, could fetch the BOM and, if required, could convert it to other formats like SPDX or anything else that's needed. Uh, Similarly, the only other platform that I've interacted with, KPack, has a KPack CLI, which has a similar KPack inspect image or inspect BOM subcommand. So I'm imagining either Pack could provide a reusable library that either already uses one of the existing libraries that converts between different BOM formats, and maybe adds some Buildpack specific flavorings on top of it if needed. Otherwise, like, they could just reuse the BOM conversion libraries that are present in the wild. So that's the current state of this RFC. Was a there was somewhat of a tangent here around container scanning as a whole, which I don't think we want to go into, because that's like a that's either a post build step, or like, even if it's live, which what Turn currently supports, I don't think that exactly fits into how currently Buildpacks own the BOM, and that they're standalone, as opposed to having a separate tool running at the same time that mounts the volume and tries to scan things. So I don't think uh, I'll prefer moving in something like an external tool that does BOM generation. So that's where my current thoughts are on this RFC. Any comments, questions?
I think I'm 100% on the same page. Have build packs, generate Cyclone DX during the build process, put the Cyclone DX into Cyclone DX formatted files, and then maybe have the lifecycle hydrate those files with more information about the layer name and the build pack and all that. This sounds really good. I agree about Turn. It's for scanning whole containers. Build packs may need a tool to scan language modules if they don't want to try to, parse package JSON lock or whatever themselves, right? It doesn't seem like that's Turn, but there are tools to do that. So like everything, the only small comment I have is you mentioned the layer being too large. The label being too large for Cyclone DX. We kind of have this problem already, and it's kind of a problem and kind of not a problem. So the config, a config blob is stored in the registry as a, like a file system layer. There's no limit in OCI for how large it can be. It's okay to make a extremely long label. There isn't really a problem in specification for it, but some K8s clusters with some, there's like one little bug in containerd, right, somewhere that creates some edge cases where it's bad. So I think regardless of whether we do this or not, we already have that problem. Our BOM is already too long for those cases. And so I'd kind of recommend taking that into a different RFC. I think I've talked to Emily or somebody about this, where we probably need to support a different label for long BOMs that kind of indicates, nope, don't look in the label, look in this layer that's appended onto the end of the image or something like that. Or maybe in a different image, I don't know. But I might take that out of this discussion, because I think it's equally applicable regardless of whether we make the change or not. I wouldn't like let that block moving forward on this. I think we could even approve this and say, yep, it goes into the config blob and it continues to be a problem, and then fix the other thing later if we need to.
I think in the last working group meeting, it was explicitly called out that we want that change in this RFC, given that this would open up Buildpack authors to use a lot of better tooling, which would generate larger bombs that they might currently do. And this is a problem that doesn't come during the build time, right? Like you can still push these things onto your registry. It pops up later during runtime, and the idea was like we may be putting in this RFC, which would cause a change, which would have authors try and create better bombs, and then later on discover that okay, all of these images that we've created with these large labels are killing their Gates cluster. So
It makes sense. I
so
feel like it's already broken pretty badly. This already happens, so I'm not like, and I agree that that's a scenario we should try to avoid. If we can get the other RFC through, if we can implement them maybe in an order where that's through. But I don't think deciding what that should look like should block the decision-making process for whether we switch to Cyclone DX and standardize on the thing. So I think we could put in the RFC that before this gets implemented, we need to figure out this problem. But I don't want to have to figure out how we're going to solve that, moving things out of the label in order to come to consensus on what the API should look like for Cyclone DX metadata, if that makes sense.
would it be appropriate to call it out in this RFC that that's a problem, and when this is implemented, the sibling RFC should also be implemented at the same time?
That's totally what I would recommend.
Yeah, I was gonna ask, is there a point of contention right now with the moving of the bomb metadata into a file format? Or is it just to keep it a cleaner discussion?
It's actually, to me, it's neither of those things. It's that I think we have to make some decisions about that. Like, should it be another layer? If it's in another layer, how is that layer referenced from the other label? Is that by diff ID? Is it by digest layer? Probably makes the most sense. Does it need to be multiple layers if we're going to split the, if we have a build time and a runtime one, should the build time one be in there? If it's a file, what should the file be called? What should its path be? Do we need to, do anything to prevent it from being accessible at runtime? Is there a security issue with the whole BOM of the image being accessible to the runtime process? Probably not, but it's worth talking about. I don't think it's going to be contentious. I just think it's its own can of worms a little bit, and it's not really related to making a decision about how we want to deal with the metadata. It just, the metadata happens, or we should be strategic about how we roll it out so that we don't create even more images that might have this problem with containerd.
Cool. Okay. Yeah, because I think two of the questions I had kind of leaned into how that would be implemented. So I think maybe just for reference into that separate RFC, the two questions that came to my mind, where I know in the past we talked about potentially having some other things outside of Buildpack specific things that may be in the base image, and how this would work with like rebase, right? We'd have to replace that potentially in a rebase scenario, that layer with the SBOM information, if it does have base image information. The other thing I had in mind was, I get that it's going to be stored in a layer, but from a platform perspective, I think it'd also be nice to be like some sort of output in the same way that the report TOML is, so that we could have it as a file without having to then go pull down another layer or the layer yet again, if that makes sense. So those two little things.
Very supportive of both those. I think it should go in the other RFC for sure.
I have one clarifying question and then another question. So I from everything that I've read and everything that I feel that I understand about this, the idea is to get rid of the current bill of materials fields inside of build and launch, correct? Like build.toml, launch.toml. Like we wouldn't have those anymore. There'd be no more existing TOML table of bill of materials. Is that correct? Okay, cool. That's the clarifying thing that I wanted. The follow-up that I have is I'm fine with picking Cyclone DX or SPDX or whatever I do have concerns about the ability to actually easily convert between the two and how lossy it has the potential of being. So I have some concerns about. I think part of the reason I was one of the maybe potential proposers of we have our own table and then we do our own internal conversions, which I agree feels really bad. So I don't want to come out here and say that we should definitely do it, but I do have some concerns about potentially putting ourselves on like an island, because I think that makes us less accessible to people that are doing these like security and compliance scans, because a lot of them are limited by the tooling and limited by their ability to change what tooling they use. And so if we don't support the correct format, I have concerns that we're going to just not fulfill their use case at all.
My understanding is that Cyclone DX is fully convertible to SPDX without loss. Is that, and that gives us the two most popular formats. Is that wrong?
So it can be converted without loss. The issue is finding the right mappings. Without loss in the sense that like there are obviously things in Cyclone DX which can't be converted to SPDX, like these freeform tags. They would probably go in some random annotation comments in SPDX, which are not as structured. So there's a way of preserving information. Whether that information is correctly scanned by the following tools is a separate matter. For like really popular pieces of information like licenses, the version, and the package name itself, those are mapped and defined by the NTIA working group. So like the major things that these scanners would look for are sort of mapped. Any additional information you put on top of that is like Cyclone DX specific or SPDX specific may be lost because there is no defined conversion between the two fields.
Could we define a, like a, I don't know if you call this almost a subset of Cyclone DX, where some of the arbitrary, like you mentioned, the properties hash, some of the arbitrary fields are defined in the Buildpacks case, and Buildpacks should use specifically named fields inside of that for writing things like what's the SHA of the binary URL, what's the source URL, things like that. If we define those up front in the project, then ideally those would get converted in a predictable way over to SPDX. And so then we could say, here's what it looks like in Cyclone, here's what it looks like in SPDX, convertible between the two formats. We have fixed fields that everything can parse. All the build pack things look the same. And it's very unlikely that we're in a position where we're not supported by some tool, because who's going to choose something that's not Cyclone DX or SPDX, hopefully.
So then that sounds like you almost want a style guide on top of Cyclone DX.
Yeah.
Okay.
One thing I do want to note is like some of the mappings are predefined, like well, not predefined, or have been defined by the community at large between SPDX with and Cyclone DX. We should keep that and try to map it to some of the existing fields used by popular build packs so that they have a migration path. But I don't know if I feel very strongly about like putting a style guide on top of the properties thing in the spec. We discussed having like a best practices thing. Maybe that's a more appropriate place to put it, so that people have a common reference, but I don't think it should go in the spec, and it should really be left up to the build pack authors. And also, if we put it in the best practices place, then we can update that recommendation based on what tooling, like what community tooling is actually using. If you put it in the spec, the conversion process is a bit like changing the spec is a lot harder to do than changing.
Can we come up with a schema in the RFC, and then after we know what we're talking about, decide what level of standardization we want for it? I don't disagree. It seems like it'd be easier once we see the data that we're trying to codify.
So that's like one of the primary challenges of like this SBOM RFC. The issue is all the SBOM tooling is sort of divided into these three sections: the tools that generate things, there are tools that transform things, and there are tools that consume them to produce like other reports. Now, uh, although as the Buildpacks project, we're mostly just on the creation and um, possibly transformation side, we should be aware of the consumption as well in order to make these decisions, like what's best. And that landscape is huge and wild, and there's no community consensus even outside of the Buildpacks project on like what's the best XYZ. Um,
Just mean like, Forrest, you got a bunch of fields in your, build pack tomls for Potato project, right? Can we get those, into the discussion in the RFC so we can talk about what things we might want to standardize just in the very constrained case of what people are using it for right now?
Sure. But I would also like to point out that because we've up to this point been doing an ad hoc bill of materials, it may be worth discussing even within Paketo, because we're currently in sort of the process of trying to codify what pieces of information we care about. Like discussions even there, like, well, if this doesn't appear to actually be something that is important to building a bill of materials, why should we continue to collect and use it if it's not part of whatever given format we're looking at? So I think I mean, we can come forward with some of the stuff like the source URIs and stuff like that is a good example of that. But for the most part, I don't know how. I'm conflicted, because if it's not an important field inside of a bill of materials standard that already exists, maybe it's not an important field for actually accomplishing what needs to be done with the bill of materials. So I'm all for taking into consideration what we have currently, but I'm not married to any of it as well.
Yeah, but one thing we should consider is that all of these BOM formats are evolving quite drastically because of the recent changes. So they have had to adopt and accommodate a lot of these random fields, which they previously thought were not necessary, but now they're realizing they are. Really like this RFC is from when I started researching into this, like it has grown a lot, and even the community consensus around the standard BOM format isn't there. Like, and there's also a lot of like, I think politics, surprisingly, US government politics are influencing SBOM formats a lot right now as well because of the executive order, and the landscape is changing quite dramatically. It has in the last couple of months. So I don't know if you want to wait for all of that dust to settle down and then pick one, or should we just roll with it now? And like,
I guess my take would be to answer some of the questions, the open questions, one by one, and see which ones still stand. Like, I think the one about a custom format, I know Forrest, you kind of voiced your opinion on that one, but I am curious how that would solve anything or mitigate some of the data loss. Once you're translating from, let's say, that format into Cyclone DX, you're going to have to figure out where to put it in Cyclone DX, right? So if we do that as a superset and have some sort of defined fields of where you could find something as important as like the source URL, then we already have something that's a lot closer to already consumable by third parties that then can be translated to something else based on those guidelines or best practices that we kind of set up, right?
I think in Sam, maybe you mentioned this. I think and maybe we answer this part as well. The only problem is then you become a spec chaser at that point, where as they update, you have to constantly be chasing and making sure that your fields stay in sync, which is, it could be a good thing or a bad thing. I'm not going to pass any judgment on it right now, but it definitely adds that overhead.
Is that the current state, or is that like a very common thing? Because as far as I've been in schema world, schemas don't change all too quickly.
It's very much a current thing. Like I've seen a lot of changes on SPDX and Cyclonians, both of those sites like because of the early 2021 incidents, and then like US government deciding that everything that they use must have an SBOM. So everyone's trying to figure out the drawbacks of different formats and trying to fix them. So Cyclone DX released V 1.3 this year after 1.5 years, I believe. I think 1.2 was released in 2020 or 2019. I don't remember. I think a lot of these questions might be better answered by like the specific office hours we've set up with Steve from the SPDX Core project, and I've also asked if someone from the Tone project who deal with SPDX a lot could be involved, so that we have both the sides, the spectrum. But yeah, if anyone else knows someone more involved with the SPDX project who may be interested in joining the office hours on 17th, that would be great.
And I mean, just to step back a little bit, I think where we are now is we probably have the worst option, right? We have this like very arbitrary SBOM thing, bill of materials that sometimes doesn't even fit in the labels, and so things crash. So anything, right, whether it be Cyclone DX or SPDX, would be better than the current situation. And if we're talking about a 1.5 to 2 year turnaround where we might have to change something, it sounds reasonable to still go forward with it.
I would be happier with this. If this RFC said, we're going to use Cyclone DX, we'll merge everything together, and then we'll figure out how to get the data format looking better in the future. Because I still think it would be less, or it would be more useful than what we have, right now and how we're writing into the images. So I agree. Like, I think we should have the discussions. I think the work, office hours with people who know what they're talking about is great. But like, very pro moving forward quickly with, picking a format and, making decisions using the information we have. And then if we need to change something later, coming back on it.
I mean, I think at that point, right, like let's say 1.5, 2 years from now, we would definitely have a migration strategy if need be between whatever we have, or not what we have, what we will have, to what might be the next step.
Well, given that we have 20 minutes left and I think quite a few more things, I lost the agenda doc. Yep. A few more things on the agenda. Maybe we should move on to history. Excuse me, history beyond layers, behind layers.
And that was something I put in, and I was just curious about like the existence of slash layers and why like different build packs have like things they put into separate layers, and why it gets copied as it is to the runtime image. Like the only question I had is what's stopping like lifecycle as it is right now from taking everything that's under the build like layers build pack ID blah and putting that as an overlay with that exact part. So like the bin directory inside whatever becomes like the top level / bin directory and is overlaid on. So I'm curious like why we went with this direction as opposed to the other one.
It's really painful if the paths change between build time and runtime, because the old build pack API kind of did this. It didn't lay it out into /user bin or /bin or whatever. It didn't move the files that way, but staging happened in /temp /workspace or something, and then all the files were copied into the home directory at the end. And the changing paths meant that like a lot of scripts you had to have like processes that run at runtime that rewrite a bunch of scripts. It was a mess. And so one thing at the beginning we said is all paths written at build time should be the same as at runtime. And It's a big simplification. So that's one reason. I think not having the directories overlap, like not giving the build packs the bin directory that the previous build pack had access to. Part of that's like kind of a security thing almost. You want these isolated things. Some of it's influenced by Nix. Nix looks very similar in that it kind of creates these isolated directories. I think eventually I'd like to see a layer, like there'd be maybe a package format for a layer that's pre-packaged like that, right? You can see that being a convenient way for build packs to select what they want to install and not have to do a lot of logic to massage them into looking like a layer, And the format we chose is basically just POSIX directory paths, right? I don't know if that's helpful.
Those were like the exact reasons I could imagine. This came up because some of the use cases around like stack packs or like putting things under certain directories uh, may possibly be solved if build packs could write into something during build time, and that would be mounted at a separate route during runtime. So that's sort of where my thoughts were coming from. Like, why did we choose to go this way as opposed to the other one? I do get the build time and runtime changes. I was wondering if it would be possible to have like an opt-in into moving these things to a top level directory if you could accommodate those changes.
Your motivation is like you want to be able to essentially kind of install Ubuntu packages or whatever, right? You'd like to modify the file system.
I want to be able to modify the file system beyond just slash layers. I don't. It's not necessarily installing packages. It's changing a few files, creating a few symlinks. That simple.
I think a motivation for having everything, for keeping a strong separation between the rest of the operating system bits and the layers installed by build packs is that caching efficiency on rebuild. And so if just one build pack changes just one of its layers, right now we can swap that layer out for something else. There's no risk that there are overlapping files, which kind of would make this impossible. And so if we added an additional thing that was more combined or more baked into the operating system, there's a risk that if the operating system changes out from under it when you do that rebase operation, you've kind of leached parts of the operating system up into the higher layers when you copied them, if that makes sense. And there's some security vulnerabilities out of that. Like if something had its Etsy password, you get the old Etsy password, not the new Etsy password. You could have mismatched permissions. Like there's a whole,
Yeah, I can totally imagine the consequences. I just wanted this like on the record for my own information, like what the drawbacks are. I was thinking about some similar ones, but I wanted like some history from people who were involved in the original decision, just to sort of lay it out more concretely why we can't do this and why we need something like stack packs instead. But yeah, that makes sense.
definitely interested in ideas on how we can support more use cases though. And not trying to shut that down, just giving that context. Anything else on history behind layers, or should we move on to shared layers RFC?
Yeah, I think screen. I'm sharing the right screen, right?
Yep.
Okay. Let me go back. I think the main question was like, how would shared layers work for older platform APIs? I think that was one open question. And I think one other question that like Terrence had was, should we be putting these shared layers under like a build pack ID namespace? I think those are probably the standing items. I don't know if Jesse or Emily or Terrence have any. Emily isn't here, but Jesse or Terrence, if you have any open questions on this.
Yeah, I think those are probably the two like more discussion ones. There's Emily's comment that I think was the thing around if we needed more type, we had to get the build pack authors to actually write out the type, even if it would be the same value due to kind of distinction between stale layers.
I think she meant cache equals true here. Right.
Yeah, I don't know if I understood the comment completely,
Yeah,
but
I think like my original motivation behind putting the types there explicitly was what Emily was saying, that for a way for us to differentiate between um, whether we explicitly wanted that thing to be cached. Like there was the RFC a while ago on like setting all of these to false on each rebuild. The motivation was along similar lines. Since this was a build only layer, the only other flag I could think of was cache. So to figure out whether this would cache or not.
Wonder if it has to do with resetting those when you restore. Because if you reset them all to false and you don't know that it was intended to be reused for build, I don't know. I'd have to think about it, but
Yeah.
there, I guess along with these flags, is there, can other build packs modify that layer.toml file?
The layer.toml file, no.
The shared layer toml.
No. It's currently like, unless the build pack that created it exposes it through an environment variable, they won't be able to. The only that specific build pack who created this layer would be responsible for cleaning up or resetting things.
So you couldn't like set metadata if you modified or changed stuff in there.
No. Unless like you explicitly set an environment variable pointing to the toml file with the metadata, and the other build packs expect to write metadata there. The idea was for it to be available if needed, but not leaking it out to other build packs. I think this was a compromise between each build pack dumping in metadata, which they may or may not be aware of, versus the original build pack being responsible for populating all the metadata from things that have been dumped by other build packs. So I think at the end we decided it's fine to have metadata, but we assume that the metadata here is not accurate. I don't know if it makes sense. There was no solution to this. I think other alternatives included the original build pack rerunning at the very end, again, to fill out the metadata, or each build pack being responsible for putting in the metadata, but then I don't know how that would work with caching, because when you do a rebuild, how would that build pack know whether like if it checks for the things it originally created, how will it now know that?
We kind of said, sorry. I thought we kind of said that these layers weren't going to be layers that had things that needed metadata, sort of. This is for caching of, kind of ephemeral things. These layers can't end up in the image anyways. So we're going to kind of punt out that part.
I mean, but even like a build cache, right? Like you probably want to know like ABI compatibility or whatever of like versions that are putting stuff in there.
You mean?
Would
Like you can imagine, for instance, like a compiled program like Go or Java, right? Where I don't know why you would share the thing. Maybe you have a bunch of build packs that interact with it, but it never ends up in the launch image. So you would put it as a shared thing, and you can imagine wanting to store information on that cache, right?
But you can already use a read-only build layer that's exposed to subsequent build packs for this. This is only when you have multiple writers.
Right. That's what I'm saying. Is like if you had multiple things interacting with it, like you still would want to, because it's a build cache, I think does not exclude the fact that you may want to store information on what you put in there or how it got there.
so the use case where like it's around AVI compatibilities, wouldn't that somehow end up in the final image? Or like my original idea for things here were like a random cache dumping ground for like a lot of tools like C cache or pip cache or node modules cache, where the tools automatically have a way of detecting and reusing these things, as opposed to someone explicitly creating certain kinds of artifacts. I think when we last tried to like put all these use cases in different boxes, we didn't find a case where a real world use case where this was happening, where multiple build packs were trying to use a cache for something that was not ending up in the app image. So it was just motivated from that.
Yeah, I can't think of specific use cases where I would want metadata associated with a multi-writer layer. But if they exist, it'd be good to, make sure we account for them.
Yeah. I mean, hypothetically, it can exist. We just couldn't find a real world example. That's why we omitted it for now.
Right. I mean, there's nothing stopping a build pack from editing stuff in this layer, right?
Yeah.
It is globally writable.
I think that's why we've tried to cripple the API a lot to make sure that it's only used for cache use cases, like things like paths or like LD library paths are not set or not even exposed. And the only thing that the build pack can set here is build time environment variables. That's it. So it was based on the assumption that if we make it clear that this API is not meant to be used for those kind of use cases, and we make the UX around it that way, people won't go out of their way to misuse it. But there's nothing preventing them from doing that. Mostly because we couldn't think of a way to prevent random use cases, given that this is just arbitrary dumping now.
Nothing prevents build packs from failing to write metadata in all other cases either, right? In the end, it is based on trust.
Does that answer the namespacing question? Like whether these shared layers should be namespaced?
Well, not exactly. There were a couple of reasons why they are namespaced. One, to clean up things when the original build pack is removed, and two, so that there's no like an other build pack won't randomly go and blow up the entire shared layers cache. If let's say build pack A created a layer called cache, which is just like generic, it's called cache. And some other build pack also, which is from a completely different ecosystem, tries to create a layer called cache as well. Now it has to be aware that this other build pack may have also created a layer called cache, which I should not name my layer on. Like it has to inspect the shared layers directory for existence of these random arbitrary names, check their content, check who created it. And in that case, aren't we just namespacing it based on the build pack? So that was the
Do we need 2 layers of namespacing though? Do we need like the escaped build pack ID and official, special directories under that? Or could we just namespace them by build packs, put an env directory at the top level, and then let build packs expose directories within their build pack cache directory to other build packs?
The way it's currently proposed, it's the env directory under Buildpacks is a special directory, which the lifecycle looks into to export the environment variables. Everything else is fair game for them to create.
But could we remove one level of nesting essentially, like have shared layers and then escape build pack ID and then just env directly under that, and then not force people to use the layers structure within their build packs, cache directory, like because the layers aren't very special here, right? There's nothing special about the contents of them besides env. You wouldn't want their environment variables to overlap because one would override the other anyways. Like, it feels like you could reduce some complexity by getting rid of the individual multiple layers per build pack and just letting build packs throw whatever they want in their cache directory and expose whatever they want to their environment variables.
I think the only thing here would be if you want to cache certain layers and not cache certain other folders, or I guess not layers, but folders.
Do we need that? That was my next question. Is I see that's really the use of that build pack toml. Build pack toml has one cache flag and a metadata list that we're not sure if we need. Sort of, could we get rid of the toml file and just make everything cached?
I currently kept the toml files for like the explicit cleanup and putting some random metadata if required. We could remove that. The other thing was this means that whatever like all of these things are cached together. So if for whatever reason you have a common cache build pack that sets up a pip cache, a CMake cache, etc., all of those things are cached and invalidated together.
But the alternative would be they have these files next to them and the build pack has to change those files to uncache them. But the build pack can already uncache them by just deleting the directory, right? I don't see a big difference.
I mean, it's similar to the if a build pack updates and basically doesn't touch it, it gets deleted. So you never have stale cache folders lying around.
But in that case, I think you end up with maybe I'm missing something, but I think you end up with the stale layers in either case, right? Like it's either a whole bunch of stale layers together that the build pack has to. Oh, are you going to opt in on the cache equals true? Is that
yeah, it's the same thing as layers, that new change, right? Where like they have to opt in to keep that that layer, that shared cache layer for each one. So if you potentially move, it's the same reason why for at least whether we do the namespace or not, like that file exists for the same reason that you argued for the other one for normal layers, I think.
Got it.
That's the main use case for the cache, at least.
It makes perfect sense.
That's different from the namespace or the per layer folder thing, but at least for the toml file.
I think that makes sense to me why it's important to call out each layer individually, because you want the build packs to be able to opt into each layer getting created individually. But you can move env to the top because like out of the individual layer namespace, and then just keep each layer as a scratched thing if you wanted to, because the environment variables shouldn't overlap. I really got to drop to my next thing though. Sorry. I'll keep chatting.
Cool. I think we're over time. Thanks everyone.